Well, thank you everyone for taking the time out of your busy days. I know just before halfway through the day here, so appreciate that. Today we were going to be going over the PowerFlex 755 TS introductory. It's just an introductory presentation, more high level stuff on just features, both from performance side and hardware features like XT and conformal coding, along also with a little bit of a services slide at the end. So yeah, just myself. I'll just share my screen. There we go. My name is Austin Malahado. I am one of the Drive and MCC product managers here at Gerrie Electric. I've been at Gerrie Electric, like David said, for 9 years, and I've been doing this role for almost 2.5. The picture you see you can see my screen on the left-hand side is John Sekaris. I think John's been with the company for 20, 25 plus years, long time, like a lot of experience in the Drive and MCC world. So, and then we also have Louise Elgersma. She is our MCC specialist. So we make up the product manager team, and of course, there's a bunch of us that support a wide range of Rockwell products. A little history there. So into the presentation itself, we'll go right in. Change my slides. There we go. So this first slide will be just the PowerFlex architecture class portfolio. So we're going to be talking about the TS, the drives in the middle there, but I'll actually start on the left and then on the right and then back to the middle. So on the left, we have the original PowerFlex 753 and 755s. Most, if not all of you, will be familiar with this drive portfolio. It's been Rockwell released this back in 2010, 2012, and it was the upgrade or the next version rather from the PowerFlex 700. So their general purpose drive came in as a 6-pulse drive in various horsepowers from 1 horsepower to 1800 horsepower. With that technology, the force technology, just before COVID, Rockwell released the 755, the first version of the T family, which was the 755 TL and the TR and the TM actually. So both those. The TL and TR are an active front end drive, so they're not your standard 6-pulse drive. They have 6 IGBTs in the front, and we'll talk a little bit about what the differences between those on the next slide. And with the active front end, they're able to mitigate low harmonics on the front end of the drive and also able to do regen back onto the line. The TR would be the regen low harmonic VFD, and the TL would just be the low harmonic. The TM is a common bus supply drive. It could be made up of regen and non-regen drives, so it could have multiple styles of the 755, and that would be a common bus system VFD. With the T family introduced the total force technology, and the total force technology was operational intelligence, adaptive control, and flexible high performance control. We'll go over what those exactly mean in the slides to come. So we have this new technology, but to bridge the 6-pulse drive into this total force technology, Rockwell introduced the 755 TS drive onto the market. Currently available right now at 480 volt, and I know we're obviously in Canada, and we are predominantly a 600 volt market. The 600 volt drive is expected to be released by the end of the year. So by the end of calendar year, so more to come on that. And that is bridging the gap from the original 755s into the T family, introducing that into the total force technology and such as SIP security and some really cool adaptive control features that we will go over. So that's a TS drive right there. So just a little bit on the power topologies. On the right is AFE, which stands for active front end. What that entails is typically on a VFD, we have 6 SCRs on the front end of the drive. That's rectifying our AC voltage to go to our DC bus, DC capacitor bank. In this case, however, regarding the TL and the TR, our active front end drive has 6 IGBTs on the front, thus allowing to create a very low harmonic speed drive. So we control the front end of the rectifier, which is connected to the AC mains to ensure that harmonics are kept to the lowest possible. Total harmonics be limited to a 3 to 5% over the operating range of the VFD. What does this allow us to do with the harmonics? Well, typically, if we had harmonic issues, we would put a 3 or more likely a 5% line reactor on the front of this drive. But with this technology built into the VFD itself, thus the 6G IGBTs and the companion of the LCL filter, we're able to actually do and mitigate those low harmonics within the VFD itself. Advantages, again, certain advantages of that are allow for regen, specifically on the TR side, and allow the DC bus to be fixed and stable rather than fluctuating with the line. This creates a unity power factor throughout the entire operation or load. So again, we won't be focusing too much on AFE. We can certainly talk more about that as John McAngelo will talk a little bit later on our VFD drive demo van. I believe that is a TL drive. TL drive. So more on that. We're going to be focusing on the 6-pulse VFD, which is the TS, and that's just your standard, similar to the 753, 755, and any standard VFD. Six SCRs in the front, which again rectifies our AC voltage to the DC, and then out to the DC bus to the 6 IGBTs in the back end, and that's where we get our pulse width modulation. So just a little power topology review there. Okay, so as I was saying earlier, we bridged the 755 with the 755T technology, and that T technology is the total force. So, new generation, but familiar feel, familiar form factor, familiar parameters, familiar communication and I/O. We're not deviating and reinventing the wheel with this new VFD. We want to keep a lot of, for better lack of word, commonality between this next step between the 755 going to the 755 TS. Just a little bit about, before we just get more into commonality, just a little bit about what the TS entails. So we're going to a 1 to 4 horsepower range. That's at the 480 volts. I expect at 600, the high range there will be 350, 300, just basing off what we did with the original 755. Operating temperatures are similar to what the original 750 series is, and that's negative 20 degrees Celsius to 50 degrees Celsius without the D rating. If you did a D rate, so that means, if you had a 10 horsepower motor and you upsize the VFD, so the VFD is not running as hard, we can actually get up to 60 degrees Celsius, which is pretty good, especially for those HVAC or HVAC applications on top of a rooftop or just, a high temperature room. Supports up to 5 option cards, similar, so we're still keeping that similarity again to the original 750 series and what that can do. The environmental for IP range will be IP, open type or IP20 with the NEMA 1 kit. IP54, so we're getting to that NEMA 12 range, and also the XT enhanced corrosion protection. That is an optional for the TS, but a standard for the TL and TR. And we'll go over what exactly that XT enhanced corrosion is, because not all conformal coating is made equal, and we'll define what that is. Easy configuration. So again, we're still doing the Premier integration, of course, with our Studio 5000. These drives can certainly do standalone applications with just using CCW and programming through that. But nonetheless, we're still, this drive is more than capable of still doing that integration with Logix in the Logix platform. Here's a difference. So the original 755 had one or single Ethernet embedded port on its main board. The TS drive, similar to the TL and TR, is coming with a dual embedded Ethernet ports. There'll still be dual Ethernet card options if in case you needed more ports. But now we're getting into the embedded dual ports, so we can do device level ring right out the box, as an example. We still, of course, have device logics and the T-Link high-speed fiber optic. This we could certainly have more conversations for those who want. This is not the same, but somewhat similar idea to the S-Link card. for drive to drive communications. There is differences between the two, so please don't confuse them with being the same. But instead of using as a speed reference for peer-to-peer drive, we're using a torque reference. So there is some differences. SIP security is a new feature on the PowerFlex 755 TS. And we'll certainly dive into what that is as well. Yeah, maybe a little bit of a regurgitation slide, but again, I just want to speak on the commonality. The commonality helps us reduce us and the customer reduce inventory and spare parts. So your original 755, 753s, these communication cards will have the same form factors as the 755 T family communication cards and IO, along with the HIMs as well. There are some differences when we get maybe into the XT. There will be XT option in communication cards. That would be more so for the platforms of just the T family. But your standard plain Jane communication IO cards, feedback encoders. Again, there's going to be a lot of commonalities. Please don't think because you might have a 753 or 755 making that jump into the T family that you got to change everything. That's not the case. In comparisons to maybe when we went from the 700, the 750 series, there was option cards and IO changes from a form factor perspective. Okay. Yeah, so we're going to dive right now into the total force technology. Bit of a buzzword there. What does that mean? Kind of really highlights three main pillars: flexible high performance motor control, operational intelligence, and ease and optimization. So flexible high performance control is the drive's power range, voltage class, and performance capabilities will soon be able to meet the requirements of a wide range of motor applications. This means you can use a common drive for multiple applications, which can simplify supports. Operational intelligence, which is the predictive analytics, predictive maintenance. This allows a built-in predictive models to help forecast the remaining life of drive components. These insights will help you reduce unplanned downtime and maintenance costs by replacing components as needed. And so, as great as these VFDs are, everything that, doesn't matter what you're dealing with, TVs, iPhones, everything from a component standpoint has a life cycle. So these VFDs can really give you some great insights on how long those components have, and also how long they've been running as well. Last, ease commissioning and optimization. So this is this is referring to the adaptive control. The drive monitors machine characteristics that can change over time and automatically compensate for changes. This helps you commission the drive quicker and maintain it for the life of the drive without really a tuning expert. It also helps reduce mechanical wear and tear and improve uptime. So again, high level, we can go into really what that means. Okay, so referring to the flexible high performance motor control, we've added pretty much a similar control modes from flux vector, senseless vector, volts per hertz, economizer mode. These modes can be found in the original 750 series, but where we're kind of getting into more of new territory is the performance side. So high bandwidth, torque accuracy, disturbance rejection, and velocity tracking, all through the adaptive control, we can really mitigate these issues. And I have a couple videos to kind of show what I mean by that. Again, I know it says 440 volts. That's what's currently have on the market right now. And but again, please stay tuned. We are a 600 volt market, and 600 volts will expected to be ready before the calendar year is over. Motor type, so we can get it into your standard induction motors, permanent magnet motors, and synchronous reluctance motors as well. So we could support, those are the three main motor types, so we can support with this VFD. And again, options, safety, input output communications, similar to what we've had in the past. Not much change there. More so change in terms of those cards are now going to be offered from an XT perspective. So those extreme environmental conditions. Okay, adaptive control. So this is certainly new. This is actually we're very excited about this. So the patent drive analytics, we can help increase performance and decrease commissioning time with the three main features here: adaptive tuning, load observer, and bus observer. I'm going to be more so talking about adaptive tuning and load observer. Bus observer is an option, but that's really more so on our TM drives that use a common bus. So yeah, I mean, we could, if you had more questions and you want to talk about that, maybe at the end of this presentation, or maybe just email me or John myself, we could certainly talk about what that entails. But yeah, we'll focus on adaptive tuning and load observer. And just actually maybe, so I'll just take a step back, what adaptive control is. So that's the three features I just mentioned. So automated commissioning and optimization is made possible thanks to adaptive control. A suite of features include the total force firmware. This includes adaptive tuning, load observer, bus observer, and enables our anti-sway capability, which is a really cool feature. I also have a video on that. These features automatically learn the machine and adapt to the operating conditions without user intervention. These features compensate for changing inertia that the motor may be trying to rotate wear and tear in the mechanical system components, as well as initial manufacturing tolerances. Adaptive tuning learns those mechanical dynamics and automatically tunes them out. From the customer perspective, this gives them, in many cases, a tuneless out-the-box experience. They don't need or should not need to become a tuning expert or retain the special skill set on their staff. Not that there's anything wrong with that. Of course, there's nothing wrong with being a tuning expert. But a tuning drive could take up to 4 hours at times, especially on those complex variable load applications. But right now, with these features, we can literally get it down to 10 minutes, and maybe at worst case scenario less than an hour, compared to the previous. Every drive can be deployed with the same configuration across all lines and all facilities. This ease of use no longer requires an expertise to deliver the performance that is needed. That's not in every case. There are some complicated applications out there that might need a little more touch from an engineering perspective, but still. We are now able to resolve problems easier with these VFDs. The level of complexity and expense that is required from an initial machine design standpoint is also improved. So instead of having to be machined and built with extreme precision, we can solve a lot of problems electronically instead of mechanically, reducing overall machine cost. In the past, balancing performance, robustness, and ease of use has been nearly a struggle. Being able to do all three is what is unique about these features, significantly impacting how quickly a machine can get up and running, especially with performances typically if you have that machine. It doesn't have the most precise mechanics. You have to tune the machine, then retune the machine periodically as the system runs. Components wear, loosen, and stretch, causing the mechanical system to become less rigid. Especially when that part is replaced, the VFD would typically require additional tuning. Without proper tuning, mechanical wear can accelerate and cause mechanical vibrations and resonance in the machine, leading to additional downtime. Historically, the only weapon to combat this was to detune the VFD on the system, detune the drive or the system, Reducing performance to avoid exciting these vibrations, now that these features can automatically compensate for them, leading to much higher level of response for tuning than we could previously achieve. Previously, customers are now seeing levels of performance that have never been seen before, thanks to the adaptive control features. And I know there's a lot of words there, a lot of verbiage. We'll show you some examples of what that means. So again, a good example of this would be a winder unwinder. Those variable loads that don't have a consistent inertia on the motor. They change as the product moves and varies. So let me see here. Just want to see where we are. Okay. So an example of this, if we got it in the oscilloscope out and we just saw some frequency, some feedback, some trending rather. we can actually monitor. We can mitigate those changes on either the high frequency, which in this case it might be bearings, or the low frequency side, which would be the flywheel, the adjusting of the load inertia. And with those features, I will, sorry, I'm running two screens here, show exactly what that means. So in this video, we have three different trends here. For better lack of words, the green would be our low frequency side. So that would be our changing load, and the red would be more so our motor bearings, the high frequency side. And with these features that I just previously mentioned, with adaptive tuning and load observer, and that's just monitoring the load and also changing the notch filters, we're able to actually mask those resonance frequencies. So I'll play this video. So in the first, there was no features turned on. You heard a lot of resonance frequency and some feedback. So as the loads have changed, there's adding a lot of wear and tear on the motor. So now we're going to start to turn some of these features on, and let's see the performance we get back. Okay. Okay. So it was, some of you may or may not have heard, it was kind of better with just load observer. We're monitoring the load, the VFD is monitoring the load, but we'll notice we get the best performance when we have load observer on and enabling the notch filters with adaptive tuning. Much more smoother response. Our trending looks to be, from a rigid all over the place to essentially a straight line. And with these features, I'm just going to turn those features off and back at it again, right? So you can see with these features, we're able to monitor our changing of the load and also to account for any mechanical wear and tear that might cause those resonance frequencies. We're able to mask that and also to adjust for any load changes. This is a new feature in the T family drive, so we're very excited to share that. In this original 750 series, you were able to change notch filters, but they were much more a manual process. So again, that comes back to that you had to be more of a tuning expert. With these features now, we're able to really just turn on parameters, turn on features such as load observer and notch filters, and able to mask out those disturbances on the motor and just get a much more smoother motor performance overall. So again, high level, we could, how the VFD does that. And there's a lot of engineering behind that. If you want to get back into and have those conversations again, we could certainly get in touch with John, myself, Steve Book, and we go over those features more from an engineering perspective. Next slide here, we're going to talk about three features. We're going to specifically focus on one with the anti-sway, but the torque-proof control. You might have seen this word back with the 755. This is a feature from the 755. So again, it's not going anywhere. If anything, it's been enhanced on the 755T. So those lifting, crane, hoist applications that can have a lot of torque regulation, regen. This drive can do that. For the regen side, that would be again more for the TR and the TM, not the TS, because the TS is a 6-pulse drive. If you had some sort of regen though on a TS VFD, you can certainly use a dynamic braking resistor. That's not going anywhere. It still has the dynamic braking transistor terminals that we can wire back a resistor to. So if you had a TS with an application that does have regen, we could still combat that with our dynamic braking resistors. Anti-sway is what I want to focus on. It's the capability to improve safety by efficiency and reducing the swing of a moving load. So think of a pendulum, right? And how that can continuously swing until it's run its course. So again, just more so on that. Let me just So with anti-sway, we can automatically control load or sloshing of fluids without the need for auxiliary sensors. So before we would be, in applications, we'd be using sensors, external controllers, or just extremely complex programming to mitigate this, which, what are we trying to mitigate? Helping prevent the pendulum effect. Built-in drive capability will help increase productivity and machine reliability. And even from a safety perspective, swinging loads with liquids is not ideal for any case. So let me show you a video, again, high level, but and how we would combat that. Okay, I'm going to turn this volume down because it's pretty loud, this one. Maybe not off, but okay. So again, obviously a small demo, but it's going to get our point across. So we see that's anti-sway disabled with an enabled. No pendulum effect. Very smooth. Okay. Really cool feature. A lot of engineering went into that. I actually saw that lab personally when I went down to Milwaukee Mech 1 at Rockwell. It is a pretty cool feature because when you really see that feature disabled, that thing's swinging like a clock. So with you can imagine now. Let's take that into a real life scenario with massive cranes, massive loads. Rockwell has obviously proven this. It's not just on a small demo. And we can literally, again, have those loads not sway when the crane is moving from left, right, or whatever it may be. Really, really cool feature. A lot of engineering. Again, high level, just representation of what I've been talking about. If you have more questions on that, we can certainly dive into that at a much deeper level. SIP security is a new feature on the T-family drive. Security as a whole, as we get into, especially on this Ethernet network platform, we want to protect the users from malicious communications. So SIP security will increase your security for your smart machines on networks and manufacturing equipment. It enables devices like the PowerFlex 755T to improve the security of your plant and to minimize the risk of cyber incidents. SIP security provides an encrypted secure transport layer in an Ethernet IP network to help protect the drives from malicious communications. Such as that would be authentication to help prevent unauthorized devices from establishing communications, integrity to help prevent tampering or modification of communications, and encryption to help prevent disclosure of data. So, there's a lot of proprietary procedures that our customers, you guys have, and we want to keep those secure, right? So with this feature, again, high level discussion, but with this feature, we're able to secure. In this case, I'm talking about the PowerFlex 755T drive, but your process as a whole, I believe as well, there's other end devices coming on to this platform with SIP security. It's not just the VFDs. So excited about that. Okay, so now we're going to talk about the operational intelligence, predictive, and which will lead to predictive maintenance. So predictive maintenance is taking a proactive approach to operation and maintenance with diagnostic data, and that continuously will monitor your VFD health and compare it to the current performance of the application settings. So it's not just running and seeing how long your VFD has been on or off. It's also monitoring how long it's been on with the addition of how hard it's been running your specific application. So with that, it will calculate the expected life of components based on actual operating conditions, real-time information allowing you to take a proactive measure and help reduce unplanned downtime and develop an effective maintenance plan. With the patent algorithms project on the remaining lifespan of drive components such as fans, buses, LCL capacitors, IGBT, relay contacts. Contextualization of real-time data from the most advanced set of onboard sensors to leads to clear, actionable, and full diagnostic and predictive analytic insights. So, what does, in hindsight, what will that allow the user to do to see that might compromise drive or motor health, such as blown fuses, component runtime hours, increasing temperatures. This VFD on CCW and I believe on Studio 5000 as well. I know for sure CCW has a faceplate called predictive maintenance, and I will show that on the next slide right here. On the right, that's an example. So you might recognize this for CCW. On the T drives, we have an extra tab under the address called predictive maintenance, and we can go through our different components on our drive to see where they are on the lifespan. Rockwell uses their mean time between failure algorithm, which is an algorithm of testing on all their components and how long they should last, and also how long they should last while being depending on how hard they're being run. So again, this is proactive information to give the user to see the predictive remaining life on their components. You could do this on the original 755 for some of the components, but you had to drill down into the parameters. It was a lot more manual process. We also used to have, we still do, have Excel sheets on how long these components would last and maybe recommended changes on these components. But now with this technology, we're taking the manual processes out and making it a lot more user-friendly, in your face, to show the end users on where the VFD stands from a life cycle on its components. Let's see. Yeah, so just again, some little graphics they're showing. Energy savings. As technology, not just drives, TVs, your fridges, as technology has moved in the future, and as we're moving forward here, the component levels have become a lot more energy friendly, energy savings. So the PowerFlex drives are designed with efficient internal components. These savings control modes for efficient application authorization, energy efficient moves, energy pause, and economizer mode. And I'll go over a little bit on economizer mode. So economizer mode consists of the sensorless vector control with additional energy saving functions. When the steady state speed is achieved, the economizer becomes active and automatically adjusts the drive output voltage based on the applied load. By matching the output voltage to the applied load, the motor efficiency is optimized, reducing the commands for the reduction in motor flux current. So again, it's essentially, so a conveyor might be one, as a conveyor is running and there's different loads, or there's no load, the VFD will reduce its command for motor flux current. So just saving those extra energy that might not be needed, and maybe from an hour to hour, day-to-day perspective, might be minute, but if you look at it from a year perspective and long-term of having these modes applied, from a yearly perspective, we could really see some energy savings for the end users. Next deck of slides will be on the corrosion. So the corrosion, the XT version for this VFD is an option. It's not a standard. So we certainly have just the standard 755 TS. Little note on XT, if you go for the TL/TR version, it's a standard on that version. So there is no deviation there. If you order a TL or a TR drive, it will come as XT. So XT VFDs, corrosion resistant components, specifically for those sulfuric acid or just very hard corrosive gases that might be in the air of or the environment of the plants. Don't want to pick on this group too much, but I know that the tire industry is a popular one where corrosion gases really need to take into account, because those gases, if not taken into account, can cause havoc on industrial and automation components. Enhanced conformal coating. So not all conformal coatings are made equal. This is true. Our VFDs 750 series boards do come standard with conformal coating, but the enhanced conformal coating really from a corrosive perspective, really extends the life of our components. And I'll show you the two a picture of the two boards, one that has standard conformal coating, one that has XT conformal coating, and you can see the difference with the dendrite growths. And those are growths that can cause havoc and shortages on our components. And this is tested and validated. I've actually I was at last year. I went to again Mequon, and I was actually was able to visit the state-of-the-art mixed gas test chambers. So Rockwell has this chamber where they actually put their components at an accelerated rate to replicate long-term exposure. And we can see the difference between standard IGBT conformal coating and XT conformal coating on IGBTs, which will be in this next slide right here. So the standard IGBTs, again, has conformal coating, but not enough not rated conformal coating for long-term exposure. That's the key word. There's long-term, and you can see there the dendrite growths are growing on the high voltage conductors. Well, unfortunately, these can cause shortages, which shortages can cause havoc on internal components and essentially damage your VFD, your PLC. Any type of electrical component, these dendrites can cause havoc on. With the XT conformal coating, you can see here again, put through the same process, the same long-term exposure process in that gas chamber, and you could see essentially no dendrite growth, specifically on the voltage conductors. They still have their copper color to them. It was a pretty impressive room, and I got to meet those individuals, those engineers at Rockwell. A lot of work's gone between this, and there's a lot of white paper documentation on this, so that we're not just these aren't just a bunch of buzzwords. This is a patent standby proven process when it comes to their XT on their VFDs. With corrosion, with corrosion, you can have unscheduled downtime. But with the XT version, we reduced that. So we reduced the unscheduled downtime in corrosive environments. We reduced the installation footprint for corrosive solutions, and also reducing the cost as well to reactive maintenance. So with that, we're eliminating, or maybe eliminating is not a good word, reducing those that which can cause again havoc on our process. Okay, so I talked earlier about commonality. Well, here's something that is different when it comes to the 755T drives. Is we're now introducing XT conformal coating on option cards. So as you can see on that page here in examples below, you might recognize some of those from just the regular 750 series, the IO, the safety cards, the encoders, and the universal feedbacks. Well, now we're offering that on an XT platform. So not just your VFD can come at an XT rated. The option cards the option cards come as XT rated as well. The same features and functionality as the standard option cards, just XT rated for those very corrosive environments. Oh, sorry. I want to talk a little bit about our lifecycle support services, not just drives, but for all Rockwell as a whole. So we want to be with you in every step of the journey. We certainly our focus is not to just sell you guys stuff. Obviously, we are a sales company, but we also want to be with you every step of the journey on a support level. So whether that would be a Tech Connect support contract, so you guys have 24/7 support with Rockwell engineers, or an asset management standpoint with parts management agreements, and be able to have spares on site that allow you to be able to pull spares and not start the warranty clock until you actually pull those spares, because people have spares obviously on site, but that warranty is being eaten away as that sits on the shelf. So we have really some really unique um, um, agreements and services rather, that can help you spare up on site but not eat away at that warranty. Again, that's a very high level. We can certainly talk more about those. Brandon Morell is one of our service reps at Gerrie Electric. His contact info is at the top right there. If you can't get that, or if you can't screenshot that, give myself a call. I can get you introduced to the right individuals at Gerrie Electric, whether it be Brandon Morell, Luke Young. We can get you on board just to even have the conversation of what these really mean and how they can help you in your processes. Because we want to be with you every step of the way, and we want you, the customer, to achieve your goals. So along with those agreements and those tech connects, we also get into startups. We can also have the ability to do startups, whether that be with our own Gerrie ASP service technician or field service engineers, depending on the application that might require. Those crane hoist applications as an example, would require a field service engineer. But we get into the services side of the drive startups training. We actually did, and some of you might be on this call, we did a drive headquarters training last Tuesday, and we got one coming up Thursday as well. I believe that one's full. And then that's actually on the 755 TS. So some of those features that I might have talked about, you might have probably seen during those labs. We have more intimate training where we actually bring a Rockwell field service engineer to Gerrie Electric to go over more in-depth engineering stuff, programming, whether it be our PLCs, our VFDs, panel views, such of that nature. And we have an excellent repair and remanufacturing team as well at Gerrie Electric, obviously with support of Rockwell. And when we do a repair, we really want to describe that as remanufacture. Other repair hubs, when they repair your Rockwell devices, will repair them at single points of failure. For example, let's use a VFD, a blown capacitor. They'll replace that capacitor, and most times, replace it with non-OEM compliant components. Where here at Rockwell, we don't just replace the single point of failure components, we replace all the components, because all the components have been used and have wear and tear from an electrical standpoint of being used. So when we do a reman, we want you to get that device back like brand new. We can't use the word brand new because obviously it's not brand new from the factory. We're giving you brand new internal components. So it really is like brand new with new components that don't have any wear and tear, and you're off to the races again with that specific device. And modernization, whether it be talking to your specific account managers, your product managers, we all work in tandem. And if you have any modernization questions, we have great partners as well with our system integrators to work with you to figure out a modernization plan. So just a little bit about life cycle supports. And again, I know I've said this before, but again, we want to be a partner at every step of your journey, and again, to help you meet your goals and your accomplishments. That's pretty much it for me, ladies and gentlemen. I do want to pass it off to John McGanja. He's going to talk a little bit about some exciting up and coming things like our VFD demo and some lunch and learn opportunities as well. So I'm just going to go to the next slide and pass it off to John.
Yeah, thank you very much, Austin. It's been a fantastic presentation. Everyone, just wanted to point out, if you haven't yet registered your group to have a visit by us during one of the dates noted in your area, we'd be happy to make that appointment with your group. Just get back to us and we'll coordinate that as soon as possible. The dates are filling fast. In some cases, some of the dates are completely booked as of this morning. So please reach out as soon as you can. We'd like to have you booked, if at all possible, by Friday of this week, if you can. Next slide, Del.
Yes, sir. Oh, 1 second. Oh, wait. Is that the effort? Did I forget a slide?
Yeah, there might have been one more other. I mean, there would have been one other slide. I just want to. We'll confirm in an email through the group. But we also have a program called Signature Series by Gerrie Electric. There are 14 or so subjects, things like drives, motor control centers, medium voltage, a bunch of topics that we'd be happy to schedule a lunch and learn at your location. Typically, these sessions are obviously during lunch. For those who are attending it, there it is. For those that are attending, we would organize and pay for the lunch for those people attending your group function. Of course, there are some situations where some projects have pressing needs, and there's a number of topics that a client is interested in seeing. Well, of course, we could schedule, one topic, one lunch, every month or so. Sometimes it doesn't work out well when there's a pressing project need. So for those situations, we certainly could coordinate, if necessary, a half-day event, as an example, still over lunch. It may cover 3 or 4 topics. So that's the list. And if you're interested in scheduling anything under that signature series, just reach out to us and we'll be happy to coordinate or have a follow-up discussion with your group. And thank you again for joining the presentation and having interest in learning a little bit more about our drives. Thank you.
Awesome. Thank you very much, Mr. McGanch. I appreciate that. Sorry, I must have missed that slide. Nonetheless, yeah. So yeah, whether it be the VFD van tour or a lunch and learn, let us know, and we'll be happy to come to your facility, your place, and share that with you. And I guess we will open it up for questions now.
And just one final point: if you have some general interest or possibility that you might end up looking to book the van, just take a screenshot of the tour dates and save that to your computer or an email, and then certainly forward that email with a screenshot with the date matching to your location. If there are some locations that are not quite close to that, for example, if you're in the North Mississauga area, that would kind of fall into our Brampton Concord area of sorts. So there are some situations that you may not necessarily fit well with this, but take the closest area because that would be the area that we would match up the date with, and then we'll certainly have a conversation with booking visit for your group. Thank you.